So when we are calculating at every step, as we are increasing the number of documents retrieved, recall is increasing. As we are moving down, like to, if we say up to 8 documents are allowed to be retrieved by the IR system. As the number of documents retrieved increases, there are a chance for relevant documents also to be retrieved. So if you are evaluating up to 8, how many relevant documents are there? Around 1, 2, 3, 4 documents are there. So out of 10, when we are increasing the number of documents retrieved, the number of relevant documents retrieved are increasing. 4 out of 10 means what? 4 over 10, 14%. But what about precision? Precision at this level, 8 level, is out of the 8 documents retrieved, how many of them are relevant? 4 of them are relevant. So precision is out of 8, 4 of them are relevant. 4 over 8, 15%. But recall is out of the 10 relevant documents we have in our corpus, 4 of them are retrieved. That means 14%. If in general 10 documents are allowed, if 10 documents are allowed to be retrieved for the users, out of the 10, 5 of them are relevant. 5 over 10 means 15%. Out of 10, how many relevants are retrieved? 5 relevant. So at this level, recall and the precisions are intersecting. But the major concept is, in our system, since we are applying partial matching, as the number of relevant documents retrieved increases, recall of the system also increases. But as the recall increases, precision is decreasing, because recall and the precision of the system are inversely related. In this case now, we see that recall is, as relevant documents retrieved increases, recall is increasing. As no relevant documents are retrieved, recall remains the same. But what about precision? Precision, when we are retrieving one document, it's 100%. But then as more relevant documents are retrieved, and as more documents are retrieved, whether they are relevant or irrelevant, it's very difficult to judge from the given data. So precision is fluctuating, sometimes increasing, sometimes decreasing, sometimes remaining the same. Statistically, precision is showing a sawtooth curve, S-A-W-T-O-O-T-H. Sawtooth curve means a curve which is very difficult to analyze. If this kind of curve is we are able to plot, it's possible to analyze, because as recall increases, since recall is taking the x-axis and precision is taking the y-axis, as recall decreases, precision is increasing. As precision decreases, recall is increasing, since they are inversely related. But if you are plotting the given numeric values that are registered at every retrieval point, it will give us the one with the blue line. What does that mean? Is that possible to analyze? When we are expecting it to increase, rather it is decreasing. When we are expecting it to decrease, it may remain the same. So it doesn't show the given results doesn't show us the relationship between recall and precision. It's very difficult to say. As recall increases, precision decreases. Why precision is fluctuating? Because precision is dependent on the extent to which regularly relevant documents are retrieved by the system. But actually, since the system is working in an uncertain world, we can't expect the system to retrieve regularly one after the other. That means recall relevance, not relevance, relevance, not relevance, and so on. Sometimes it is retrieving relevant, not relevant, relevant. Then there are 3 irrelevant, then 2 relevant, then 1 irrelevant, then 1 relevant. So the irregularity will create inconsistency in the precision values, the values that cannot be easily analyzed. So the solution is what? The solution is we have to avoid the sawtooth curve. The sawtooth shape of the curve should be smoothed. That means it should be interpolated. We can take as a standard recall values, since as relevant documents are retrieved, recall is increasing from time to time, and it can be easily determined. The problem is the precision, which is dependent on the number of documents retrieved. So when we are interpolating and trying to remove the inconsistency observed in the precision values, we have to first set standard recall levels. That means from 0 recall up to 1 recall. The recall may be 0 means no relevant documents retrieved. The recall is 1 means all the relevant documents are retrieved. So in between them, we can set with a difference of 0.1. So we can come up with 11 standard recall levels. 0, 0.1, 0.2, 0.3, up to 1 by increasing the recall levels by 0.1. So we have 11 recall levels, that means. Then at every recall levels, we have to identify the maximum precision. So we are trying to come up with the precision at every recall levels. What is the precision at recall level J? Means the maximum precision registered from recall level J up to recall level J plus 1. When you are finding the precision at recall level J, we have to find the maximum precision registered from recall level J up to recall level J plus 1. Then select the maximum precision registered from RJ to RJ plus 1 to find precision of RJ. Like, what is the precision of the system at recall level 0.2? What is the precision of the system at recall level 0.2? The precision of the system at recall level 2 is the maximum precision registered from 0.2 up to 0.3. So we are trying to compare and identify the maximum precision registered from 0.2 up to 0.3. That will give us the precision at recall level 0.2. So how many values we are comparing? There are around 4 record levels with 0.2 and 1 0.3. When we are looking at the precision registered, the maximum precision is 0.67. Out of the 5 alternate values, 0.67 is the maximum precision. So the precision at record level 0.2 is 0.67. What is precision at record level 0.1? Precision at record level 0.1 is the maximum precision registered from 0.1 up to 0.2. Because our interpolation formula says find the precision of the system at record level j by comparing and identifying the maximum precision registered from Rj up to Rj plus 1. Rj, then the next level is Rj plus 1. That means it increases by 0.1. J is telling you the record levels. From the J's level up to the J plus 1 level. C is the maximum precision registered, then take that maximum precision as a precision of at record level J. So in this way, we can smooth the previous results that we have. Then we can smooth the precision values using interpolation. So first we have to set the standard record levels. How many standard record levels we have? As we said, 11, starting from 0.00 up to 1. What is the precision at record level 0? We have to go back and try to identify the maximum precision registered from 0 up to 0.1. To find the precision at record level 0, we have to see the maximum precision registered from record level 0 up to record level 0.1. How many options you have? We have 2 options. There are 2 0.1s. We don't have 0. If the first one is not relevant, yes, we will have a 0 recall. But now, since the first one is relevant, we have a 0.1 recall. But to find the recall of precision at record level 0, we have to compare from 0 up to 0.1. So we have 2 options to compare. One option, the first one, precision 1. The second one, precision 0.5. The maximum one is 1. So precision registered at record level 0 is 1. The next one is the precision registered at record level 0.1. The precision registered at record level 0.1 is, we have to compare starting from precision level 0.1 up to record level 0.1 up to record level 0.2. So we have around 1, 2, 3, 4, 5, 6 options to compare from 0.1 up to 0.2. The maximum one is again 1. So the precision registered at record level 0.1 is the maximum precision registered from record level 0.1 up to record level 0.2. That value is again 100%. What about the precision registered at record level 0.2? The precision registered at record level 0.2 is the maximum precision registered from 0.2 record level up to 0.3 record level. That is 0.67. The maximum precision registered at record level 0.2 is the maximum precision registered from record level 0.2 up to 0.3. That value is 0.67. In this way, we have to fill for all values from 0 recall up to 1. But sometimes the challenge may be there. We have only up to recall 0.5. What is the maximum precision registered at recall level 0.6? Now that one should be guessed, because as recall level increases, if precision decreases, we can guess that if the recall at 0.5 is 0.5, we are expecting at recall level 0.6, at most 0.5. So starting from 0.6 up to 1, at most we are expecting a precision level of 0.5 or less than that. But the maximum precision expected as recall level increases, since precision is decreasing, it may be remaining the same or decreases starting from the given recall level value of precision. So once we interpolate, if you try to draw the line, you can get the one with the red curve rather than the sawtooth curve, which is very difficult to interpret. But now see the pink curve. We can say that this is the precision axis, this is the recall axis. So we can say that as recall increases, precision starts decreasing. As recall decreases, precision reaches to 100% even. So then, after getting the retrieval result of precision and the recall, usually we have to interpolate. Why we interpolate? To avoid the sawtooth curve, a curve which is very difficult to analyze, interpret, and see the effect of the IR system in retrieving relevant document for the users. Interpolation is mostly gives us for a given user's query what are the different recalls precisions registered at different cutoff points that we have. When 1 retrieved, 2 retrieved, 3 retrieved, k retrieved, n retrieved. Sometimes you want to calculate what? A single value. We want to say our system is performing just with 18% precision, sometimes we say. That one also gives a sense for the users. Rather than looking at a series of values, they want to know with one number how much is the performance of the system. To measure the effectiveness of the system with one value, the well-known one, mean average precision, or MAP, MAP, or R precision. In fact, mostly the mean average precision is used as compared to R precision. Calculating the precision at R's relevant document. The mean average precision can work for whatever number of queries that we have. Even if you have multiple queries, you can apply mean average precision map for calculating with one single value to know the performance of the system. So given n queries, so externally we are dividing whatever value we get with 1 over n, 1 over the number of queries Then we have to sum for each query where those relevant documents are appearing within the retrieved list. Then since for each query we have the relevant judgment, we know the number of relevant documents expected for every query. Then after summing the retrieved relevant documents, taking into account their position, then we are dividing by the total number of relevant documents available for that query. Then after summing overall, we are dividing by the total number of queries we have. That will give us the mean average precision. See with example. We have two queries, and assume that for the two queries, we expect 3 relevant documents. Now the retrieval result shows us for query 1, 3 documents are retrieved. For query 2, 2 documents are retrieved. In fact, the result shows us the position of the relevant documents retrieved. For query 1, the first relevant document appears at the first position. For query 1, the second relevant document appears at the 5th position. For query 1, the third relevant document appears at the 10th position. For query 2, the first relevant document appears at the 4th position. For query 2, the second relevant document appears at the 8th position. So no third relevant document available for query 2. But our expectation is for both queries, we expect 3 relevant documents. For query 1, all the 3 relevant documents are available at different positions, but for query 2, only 2 of them are located within the retrieval list. So we have to calculate the mean average precision. What is the mean average precision for such kinds of results? So as we said, we are the whole result is divided by the number of queries, 1/2. Then take each query. We have how many relevant for the first query? 3 relevant. Where the first relevant document appears in the first position, 1/1. What about the second relevant document? It appears in the 5th position, 2/5. The third relevant document appears at the 10th position, 3/10. So the precision of the first document is 1/1 plus 2/5 plus 3/10. Then we are dividing the whole over 1/3. Go to the second one. There are 2 relevant documents retrieved. The first one is retrieved at the 4th position, 1/4. The second one is retrieved at the 8th position, 2/8. Again, we have to divide the result by 2. So then if you calculate the overall result, we can say that the mean average precision of the system is this much. With one value, you can calculate 1/2 for the first query, 1/3 multiplied by the summation of the availability of the relevant document based on where they are appearing. For the second one, the availability of relevant document based on their position again. Then the overall result will be gives you the mean average precision of the system. It's not an average precision. It is a mean average precision. Average of average precision. So with one value, we can say how much percent the system registered in terms of mean, average, precision. Again, sometimes we have to take into account the user's interest. We have to analyze who are the users of the system, and as per the need of the users, we have to start designing their system. Now there are three options for the users. Some users want a system that can retrieve as much documents as possible. Other users want a system that can retrieve a balance of relevant and irrelevant. So as much as possible, an average relevant document should come. There are also users who need precisely only relevant documents should be retrieved. Even if there are few documents retrieved, they are expecting relevant documents only. So accordingly, when we are designing such systems, by observing their effectiveness, we have to either relax or make tight the number of relevant documents retrieved for the users. For this purpose, we have F measure and E measure. F measure is basically used for balancing recall and precision. As we said, recall and precisions are inversely related. But when we are using F measure is trying to see a system has to retrieve as many relevant documents with a better recall without degrading precision. So when both recall and the precisions are increasing, F measure is also increasing. If one of them is increasing and the other one is decreasing, F measure is less. If both of them are decreasing, again, F measure is less. So F measure becomes high if better recall and precisions are registered. F measure helps us to calculate harmonic mean of recall and precision. That means the point where recall and the precisions can be balanced. How we can calculate F measure? We are trying to balance recall and the precision. That means 2 over 1 over recall plus 1 over precision. 2 over 1 over recall plus 1 over precision means 1 over R plus 1 over P will give you R plus P over RP. R plus P over, or P plus R over RP or PR means what? We can invert. Then PR goes to the numerator and P plus R to the denominator. Then we are multiplying PR with 2. That will give us the formula 2PR over P plus R. So we are using this formula for calculating F score, which can, some scholars are saying F1 score. The major thing is we are calculating the harmonic mean. 2 times precision times recall over precision plus recall, which can gives us a system that balances recall and precision. If you calculate given recall and precision, as said earlier, if the recall is 0.1 and the precision is 1, what is F measure? F measure is 2 times precision times recall over precision plus recall. 2 times 0.1 times 1 over 1 plus 0.1. 2 times 0.1 is 0.2 times 1 is 0.2 over 1.1. 0.2 over 1.1 is 0.18. Even if precision is high, since recall is low, their harmonic mean is 0.18. When F measure is increasing, the point where both recall and precisions are better. Not one of them, both of them. Both of them are better at what point? Both of them are better at this point. Recall is 0.5 and precision also 0.5. So at that level, you will get 0.5. Those with the red colors, you have to calculate and fill them. It's not zero, just you have to exercise. For instance, for 0.2 and 0.5, 2 times 0.2 times 0.5 over 0.2 plus 0.5. 0.4 times 0.5 over 0.7. That means when you are looking at the maximum measure registered, it's registered at this point. Next comes is this point. Next comes is this one, the point where 0.4 and 0.44, then 0.3 and 0.43. So as both recall and the precisions are increasing, F measure is also increasing. Again, the use of F measure attempts to balance the recall ability of the system and the precision ability of the system. But still, users may be interested only to maximize recall only or precision only. That means the users may need a recall-oriented information retrieval system or a precision-oriented information retrieval system. Maybe a balanced one is another case. But when we come to e-measure, it tries to include all the criteria, and accordingly we can design using e-measure by taking into account the user's interest. That is that users can be satisfied with the system. So the formula of the F measure is adjusted, and the measure formula is the same, PR over P plus R, but beta is added. So in place of 2 that we are using for F measure, we are using 2 PR over P plus R. In place of 2, 1 plus beta squared is used. 1 plus beta squared then times PR over beta squared P plus R. This is a generic formula that can be adjusted based on the beta value to make the E measure is equal to F measure, or E measure is equal to recall oriented, or E measure precision oriented. So we can calculate the effectiveness of the system either whether the system is a recall oriented system or a precision oriented system or a system that can balance recall and precision. For instance, if beta is equal to 1, assume that beta is 1. 1 squared is 1. 1 plus 1 is 2. 2 PR over 1 squared plus P times P. So 2 PR over P plus R. That means what? F measure. To get F measure, we can make beta is equal to 1. If beta is 1, E measure is equal to F measure. And if beta is greater than 1, it gives emphasis for recall. For recall-oriented information retrieval, the beta value should be greater than 1. For precision-oriented information retrieval systems, the beta value should be less than 1. That means what? When beta is greater than 1, the E measure is high for those systems which are registering high recall. As recall is high, with a beta value of greater than 1, E measure is also high. But for beta value less than 1, E measure becomes high if and only if precision becomes high. So if you are designing a system which can equate precision and recall, we have to make beta is equal to 1. If you are designing a recall-oriented one, the beta value should be greater than 1. If you are designing a precision-oriented system, the beta value should be less than 1. So such that when beta value is greater than 1, E measure is following the value of recall. When beta is less than 1, E measure is following the value of precision. When beta value is 1, E measure is following the point where both precision and the recalls are high. As at beta value 1, E measure is the same as F measure. As a result, it is trying to come up with a score which is in between, or which is an harmonic mean of recall and precision. But if we make beta is equal to 2, which is greater than 1, if beta is greater than 1, E measure is following the value of, it is near to, that means near to recall value. Just compare the E measure results we obtained at beta value 2 with recall value. It's almost near to recall value as compared to the precision value. It's far from precision, but near to recall when E measure is equal to beta is equal to 2. But what about E measure beta value at half, 0.5, less than 1? The value, the E measure score is near to precision value. 0.74 is near 1 than 0.1. The same is for all. So we can manipulate አንድ ዞር አስነሳዋለሁ እና ጠብቁኝ እያለቀ ነው ይሄኛው አንድ ሴሽን እንቀጥላለን